Our first lecture topic is going to be on representing organic compounds, and specifically, we're going to talk about Lewis structures. This is probably the first way that you've learned to represent organic compounds, and we're going to start here and start to move towards line structures, which we're going to use more often throughout the course. But we are going to need to start with this type of foundation because if we're going to talk about how molecules react with one another, we're going to have to be able to draw them and show all the atoms, show any lone pairs that might be there and might be important for a reaction. And so Lewis structures and understanding them is very important for the rest of the course. One of the things that we're going to do with our Lewis structures, we're typically going to be starting out with a formula like this. That doesn't give us that much structural information. Typically, it's written so that these atoms are kind of next to each other in the structure, so the carbon atoms are all connected to one another. In brackets, we see that we have this oxygen. Those brackets typically mean that the atom is coming off of the chain. We don't do that necessarily for hydrogens, but for other carbons or oxygens, we would put them in brackets if they're coming off of the chain. So that's just something to keep in mind for that. First thing we're going to have to do before we start drawing out that structure is to count the total number of valence electrons. One of the things we have to keep in mind while we're counting those total number of valence electrons is that we're going to add one electron for every negative charge that we have. We do see a negative charge in our molecule here. We're going to subtract an electron for every positive charge that we have. So we just have to keep that in mind when we're looking at counting our total. So for this example, we are going to go through each atom in terms of what atom it is. So we have one carbon and how many valence electrons it has. This can be found from the periodic table. And so for this carbon, we're going to have four electrons, four valence electrons. And so that will give us four towards our total. Let's take a look at some of the other ones. So hydrogen, this is going to have one valence electron, but since we have three of them right here, we're going to have three total electrons coming from those three H's, another carbon for four, hydrogen, one electron each, so two, because we have two hydrogens there, another carbon for four, oxygen for six, carbon for four again, and then two hydrogens, one each for two. We have this negative charge, so we are going to have to add one to our total. Once we count all those up, we're going to find that we have 30 valence electrons total in this molecule. And so we're going to go back to that total as we're placing those atoms on the page, making those bonds, counting the electrons in the bonds, and then figuring out, do we need to add more electrons to that structure in the form of lone pairs? So what we're going to do now is arrange those atoms on the page and place a bond between each atom. And we can get how we're going to arrange the atoms again by the way that it's written in this structure gives us a little bit of a clue in terms of what atoms are connected to what. So typically when the carbons are written in a line like this, that means that they're connected to one another. And the hydrogens that are written close to that carbon means that they're coming off of that carbon. And so we're going to start with the carbon on the end, this so that carbon on the left-hand side is going to have its three H's coming off of it. And it's also going to be connected to the CH2 that's written right beside it. So that carbon there with its two H's, that's going to be connected to the carbon that's written right to the right of it, which is that carbon that has the oxygen in the brackets. That oxygen in the brackets, it means that it's coming off of the chain. So we can typically draw that either above or below the main chain that we're drawing. And so that's going to be that oxygen there. And then that carbon is also attached on the other side of the brackets. We do still have another carbon, so that's attached there. And then we have two H's coming off of that one. And so that's what we are doing to place those electrons on to the molecule between each of those atoms because they do have to be bound to one another. For the total now, so we have 30 total electrons. Let's take a look at what we have. We have two electrons from each bond that we've already placed. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22 electrons that we have already placed. So from our 30 electron total, we're going to subtract 22 electrons because we've put those all in the form of bonds, that's going to leave us with 8 electrons to distribute now. And how we're going to distribute them, we're going to be distributing them as lone pairs. One of the things that we're going to have to make sure we're doing when we're distributing these electrons as lone pairs is we're going to have to start at the most electronegative atom, and we're going to stop when we have an octet on that atom. So if we look at our molecule above here, we do see that we have an oxygen, which is the most electronegative atom. That's where we're going to start putting those lone pairs onto the molecule. So we have 8 electrons, so we can place 3 lone pairs on an oxygen. The reason we have to stop at 3 and only putting basically 6 electrons around that atom is that we do have to stop when we have an octet, and we do have an octet once we've placed 3 lone pairs on that oxygen because we count 2 from this bond and then all of those, that's going to be 8 electrons. So we can't add any more electrons to that oxygen. We do have to move on to another atom, and we have either of these carbons we can add it to. Just to be consistent with things we're going to see a little bit later, I'm going to add it to this carbon on the right, but it really doesn't matter. You could add it to either one. So that's that remaining lone pair from our 8 electrons. So now we've distributed all of our electrons onto the molecule. What we're going to have to do next is deal with formal charge. Are there charges there? That's going to help us. Formal charge and octet is going to help us to get to our final Lewis structure. So let's take a look at what we're going to have for our formal charges. So this is step 4. One of the tips is to skip the carbons that have 4 bonds and any H's in the molecule because those are going to be neutral. So we don't have to go through every single atom. We just have to go through the ones that are more likely to maybe have a charge. So those atoms, those carbons that don't have 4 bonds or atoms that aren't H's. And so let's take a look at the oxygen at the top. So one of the things that we have to make sure that we're doing when we're counting our valence electrons is we're actually only counting 1 valence electron per bond for when we're counting it towards the formal charge. When we're counting octets, we count both of them from the bond. So that's an important difference for formal charge versus octet. And so with this oxygen at the top here, we see that it wants 6 valence electrons. We're getting that from the atom's group number on the periodic table. So this oxygen wants 6 valence electrons. How many does it have? We have 6 basically coming from those lone pairs, and then we have 1 from the bond. So it actually has 7. So we're going to take the number of valence electrons it wants, subtract the number that it has, and that's going to give us -1. So basically this oxygen is going to have a negative formal charge, and typically we don't write -1 next to it. We usually just write a negative charge in a circle to kind of make that charge stick out a little bit from the molecule. So that's what we're going to be doing a lot in this course. And then, so that's for that oxygen. For the carbon in the middle, we want 4 valence electrons. How many do we have? We take a look at this carbon here. We have 1 coming from each bond, and that's all that carbon has. And so we're going to have only 3 valence electrons. So we take what it wants, subtract what it actually has, and that's going to give us 1. And so this is going to be a positive charge. So we're going to put a positive in a circle because it's a +1 charge. We're going to do the same thing for the carbon on the right. So that one wants 4 valence electrons. How many does it have? It gets 1 from each of these bonds. So it's going to have 1, 2, 3 coming from here, 4, 5. So it actually is going to have 5 valence electrons. So we're going to take the electrons it wants minus the ones that it has, and that's going to give us -1, or the negative in the circle. So those are our formal charges. We can go ahead and transfer them to the structure in step 5 because once we've assigned these formal charges, we are going to have to figure out if all the atoms have octets. We can kind of place these charges down here. So when we're counting up octets, again, we're going to be skipping any of those carbons with 4 bonds or hydrogens. We're going to be looking at basically the ones that we were looking at for our formal charges. And so when we're taking a look at these ones, we're trying to figure out which atoms have octets. So we're going to take a look at the 2 carbons we were dealing with and also the oxygen. So for octets, we're counting 2 electrons in this bond. We have 6 lone pairs and then these 2. So that has an octet. So it has 8 electrons total around it. So that's good. With the carbon on the right-hand side, we have these two, these two, these two. So that's 6 electrons so far towards that octet. And we have these two. So that's 8 electrons as well. So we do have an octet there as well. And for the carbon in the middle, we have these 2 electrons, 2 and 2. So that's only 6 total electrons. So that carbon in the middle is a problem right now because it only has 6 electrons. So that's not good. What we're going to have to do now is figure out, is there a way we can get that atom to have an octet? And we do see that we have some negatively charged atoms right next to this one, and those are going to be where we're going to be pulling electrons from to help share with that carbon in the middle so that it can get an octet. And so that is one of the last step. We're going to be moving the electrons from the negative atoms to make the octet. So our problem was this carbon in the middle. We have 2 choices here. We can move the lone pairs from this carbon, make them share, make a double bond between these 2 carbons. That's going to keep this carbon having its octet, and it's actually going to give this middle one an octet. Or we could move one of the lone pairs from this oxygen down. Either one would be acceptable. When you have a choice, it's generally best to take from the less electronegative atom. So oxygen versus carbon. Carbon is less electronegative, so more likely that that's going to actually go and share with the other carbon. So we're going to go ahead and draw those ones being shared. So we're going to basically be moving them to make a bond in between the 2 carbons. So that's going to give us this structure where now we have a double bond between the end carbon and that middle carbon. And then the oxygen is still attached how it was. Whenever we move electrons like this, we do have to recalculate that formal charge. And what we're going to see, so this oxygen is going to still have that same charge. So we didn't touch it. We didn't do anything with that one. With this carbon, so the oxygen is still -1. With these 2 carbons, now we see that they're actually carbons that have 4 bonds, and so they're going to be neutral. They have 1 electron from each bond, so they want 4, they have 4, they're going to have 0 formal charge. So what we've done with sharing those electrons from that carbon is we've given that middle carbon an octet, which is great. This is the best structure for this molecule because everything does have octets. And we've also gotten rid of some of those formal charges. So typically in your Lewis structures, you're going to be looking for something that doesn't have a whole lot of formal charge in your final structure, and a structure where, if possible, all of the atoms do have octets. And so that's just an example of how to draw Lewis structures. Another example is given in the text as well to kind of stepwise go through, and there'll be a lot of examples in the assignment to go through for Lewis structures. Next, we're going to talk about line structures, where we're going to be dealing with these line structures then after for the rest of the course.